Yeah. Find the LCM and HCF of 6 and 20 by the prime factorization method. So they are given two numbers 6 and 20. We have to find LCM and also HCF. By which method? We have to use this method only, prime factorization method. Okay. In answer, first step, uh, prime first. So since they are mentioned prime means we have to use prime numbers. Okay. So first, prime numbers means for example 2 is the prime number. So it has only two factors, two factors which can divide these two completely. First is 1, other one is the same number 2. Only this one can divide this 2 completely, and this 2 can divide this 2 completely. No other number can divide this 2 completely. So this number has only two factors. Okay. That can divide this 2 completely. So any number that has only two factors which can divide this 2 completely is the prime number. So 2 is the prime number. So first you have to write such. Okay, I will write first all the prime numbers one by one in the order starting from 2. See, first prime number is 2. After this, next 3. This is next prime number. Next, after that 5. After that 7. After that 11. And so on, etc, etc. So till here we will keep, because till here is enough to solve this problem. Okay. First, what we will do, we will take 6 and we will factorize this. We have to write 6 as the product of prime numbers. For that, take the 6 first. Okay. Here I will take. Next, take first prime number and divide this 6. First you write like this. So take this first prime number here. Before taking, you have to check whether this 6 can be divided completely by 2 or not. Yes, 2 can divide this 6 completely. So take this 2 here. So 2 3 is a 6. 2 3 is a 6. Again, for this take like this. Now check this 3 by the same 2 whether this 2 can divide this or not. No, right? If you divide 3 by 2, you get 1.5. 1.5 is the decimal. We should not get decimal. So it cannot divide this 3 completely. Next, after this, check next number. Next number is 3. Yes, this 3 can divide this 3 completely. So write this 3. So 3 ones are 3. Okay. When you get 1, you stop the division process. Now this 6 is equal to, except this 1, take these divisors. These are the numbers we use to divide these numbers. So don't take this one, except this one, take all other these numbers. Okay. So prime numbers used for division. So take all the prime numbers except 1. So 2, then 3, multiply, put into symbol between this and this. So this is multiplication. We will also say product. Multiplication, for multiplication we will also say product. So this is multiplication or product of two numbers. See, 6 is equal to 2 into 3. 2 3 is a 6. Okay. So this is prime factorization. Okay. We factored the 6 like this. Prime means prime number. So 2 also prime number, 3 also prime number. Factorization means so we have written prime numbers as a product. So we get this 6. So that is 6 is prime factorized. If you write like this, 6 is equal to 2 into 3. So 6 is prime factorized and like this 2 into 3. Okay, so that's all. Okay, next take this 20. 20 put like this. Now take the just think whether first prime number you take. So think whether this 20 can be divided completely by this 2 or not. Yes, 2 can divide this 20 completely. So write this 2 here. So now 2 tens are 20. Okay, now again put like this. Again check the same 2 whether this 2 can divide this 10 or not completely. So this 2 can divide this 10 completely. So you can take the same 2 again. Okay. If this cannot divide this, then you have to go to next number. Till then you should not go to next number. You have to take same number. Okay. Remember this. Now to this 2 have taken here. Now 2 5s are 10. Again put like this. Now check whether this 2 can divide this 5 completely. No. If we divide this 5 by 2, we get a decimal number like 2.5. So go for next number. Next number is 3. 3 also cannot divide 5 completely. If you divide, you get decimal. So next number is 5. Okay. So this 5 can divide this 5 completely. So write this 5 here. Now 5 ones are 5. So when you get 1 here, stop the division. Now except this, consider remaining prime numbers, these prime numbers that are used for division. Now this 20 is equal to, write this 225 with space, then you put into. So now 2 2s are 4, 4 5s are 20. So we have written 20 as the product. Product means multiplication into. We have written 20 as product of prime numbers. Okay. 2, 2, 5. These are prime numbers. So when you write like this as a product of prime numbers, that is 20 is prime factorized. So in the question, prime factorization method. So we have to write like this, product of prime numbers for both 6 and 20. Okay, now this is done. Now based on these prime numbers, we can find LCM now. First we will find LCM. Now, so LCM, there is a definition you have to remember. LCM is equal to product. Okay, product of the highest power. Highest power, or you can say greatest power, both are same. Okay, highest power of each prime factor involved in the numbers. Involved in the numbers. Now I will write same thing, LCM is equal to. Now based on this definition and these prime numbers, we can find the LCM. First to see what it is saying. Okay. Each prime factor involved in the numbers. I mean, you have to consider both the numbers 6 and 20. So numbers means 6 and 20 you consider. Next, each prime factor involved in the numbers. That means from both the numbers, whatever prime number is there, prime number or prime factor. Okay, factor means that divides 6 completely. 2 is the prime factor of 6 because 2 divides 6 completely. So 2 is the prime factor. Okay, so each prime factor involved in the number. That means in both the number 6 and 20, so all the prime numbers you have to take only once. That means 2 is here, here, here also. But you have to take only once. First we will take 6. So all the prime numbers that are present in both the numbers you have to take first. That is the meaning of each. Means each prime factor means every prime factor you have to take. So first I will take, consider 6. In 6 2 is there, I will write here. Next in 6 3 is there, I will write here. You have to leave some space here. Next I will come for 20. So consider 2. 2 is there but 2 already written, so no need to write again. Again 2 is already there, so don't write. Next 5, for 5 is not written, so take 5 here. Okay na? So each prime factor involved in the numbers, so this we have got 2 3 5. Next to consider this product. Product means multiplication, that is into. We have to put into here. Between the numbers you have to put into. Okay, next what is there? Highest power of each prime factor. That means we have to consider the highest power. Before that, so this here only 1 2 is there, no problem. Here there are 2 2's, right? This is 1 2, this is second 2. So I can write 2 square. For 2 into 2 I can write 2 square. 2 means this 2 square is because there are 2 2's are there. This is 1 2, this second 2. So that is the meaning of 2. So 2 into 2 can be written as 2 square. And this into 5 I will write as it is. Now they are telling highest power, first power. Okay, so here come here, it just 2 is there, nothing is there means here 1 is there. Just 3 is there, here nothing is there means 1 is there. So this is the power 1, this is the power 1. 2 to the power of 1, 3 to the power of 1. Okay. Next come here. 2 square already power we have written. For 5 there is no power we have written. So nothing is there means 1 is there. So power. Power means you have to consider the powers. Only powers. So those are the powers. So what they are telling, highest power. Highest power means for each prime factor which is highest power, that you have to write here. First I will take 2, right? Okay. So here consider 2 here. For in 6 2 is here. In 20 2 is here. So these two you consider. Okay. These two you consider. Now consider the powers. This is power 1. This is power 2. So which is highest? So this 2 is bigger than 1. So since 2 is bigger than this 1, so this is the highest power. 2 is the highest power. So this 2 you write here. So in the definition of LCM, highest power is there. So I am taking highest power 2 here. This is highest power. Next 3 is there. Come for 3. Check here 3 is there not. 3 is there or not. Here no 3. This is the only 3. So only 1 3 is there. So whatever power is there, that you write. So power is 1 or 1. Okay. Next 5. Okay. So check here. Here there is no 5. But here 5 is there. So only 1 5 is there. Here no 5. So since only 1 5, so whatever power is there, this 1 you take here, right here. Now simplification. 2 square means 2 into 2, 4. 2 square is equal to 4. Into you put 3 to the power 1 means 3 only. Into 5 to the power 1 means 5 only. So that is equal to, now 4 3 is a 12. 12 5 is a 60. Okay. Now LCM is equal to 60. This is the answer. This is the LCM. So first part is done. Question is find the LCM and HCM. So LCM is done. So we got LCM as 60. This is the answer. Next we have to find HCF. So how we will find HCF? For finding HCF, this is same, this is same. The only thing is this definition will change. This definition will change, that I will show now. So definition I am going to write for HCF. So HCF is equal to product of the smallest power. Product of the smallest power of each. Smallest power of each common prime factor. Common prime factor in the numbers. So based on this definition, we can find HCF. First I will write same HCF here is equal to. Now consider each common prime factor in the numbers. Okay. First numbers means we have to consider both 6 and 20 common prime factor. So these are the prime factors only. 2, 3, 5 are prime factors. Then what are they telling? Common prime factor. Common prime factor we have to take, which is common in both 6 and 20. I mean in here and here. Okay, first here and here, which is common, that you have to consider. They are telling each means everyone. That means each in the sense not 1 or 2. If there are 2 common factors, you have to take 2. If there are 3, you have to take 3 common factors. So each they are telling. Each means every common factor you have to take. So you have to check this and this. First we will identify common factor in both. So that is what each common prime factor in the numbers. So first consider 2. Here 2 is there. Here also 2 is there. Okay. Here also 2. Here also 2. So common prime factor is there. So this common prime factor 2 you write only once. Next here 3 is there. Here no 3. 3 is not common here and here. If 3 is present here also, then only you have to take here. But 3 is only here no 3. So don't write 3. Next 5. 5 is here only, but here no 5. So don't write 5 here. If here also present, then only you have to take. So 2 is present here and here, so I have taken 2. Okay. So like that you have to take common prime factors. So this is done. According to this, I have taken this. So there is only one common prime factor, that is 2. Next product. Product means multiplication. See, if there are 2 numbers, we can put into symbol between those. But here there is only one is there. Okay, no need to put into here. But in some cases, if you get 2 common prime factors, then according to this definition, you have to put into. Okay, but here we got only one number, so no need to put into here or here. So just leave it because there is only one number. Next to consider power. So there is only 1, 2 is there. Now consider the powers. Now when it comes to powers, so consider here because this is already simplified and written like this. So when it comes to power, consider these two and here these two. Power means this only. For 2 this is the power, this is the 1 is the power, and here this 2 is the power. So powers we considered. What they are telling, smallest power. So consider the only powers per 2. So this is power 1, this is power 2. So in between this and this, they are telling smallest. Which is smallest? 2 or 1? 1, right? 1 is smaller than 2. 1 is smaller than 2. So we have to take the smallest one. According to this, the smallest is 1. So that one you have to take here. Okay, now we have to simplify. 2 to the power of 1 means that is 2 only. Okay. So now HCF is 2. So this is the answer. Okay. So we got LCM is equal to 60, right? Yeah. This I already explained, I showed you. So LCM is 60 and HCF is equal to 2. These are the answers. So question is that only, find the LCM and HCM of 6 and 20 by the prime factorization method. So we solved this problem. So this is the answer, 2 and 60. Yeah, that's all. If you want to say anything related to this topic and the concept, please mention in the comment, okay? And subscribe.